back to the channel. We're solving August 4th question today. So the range sum of sorted subarray sums. So you're given an array that consisting of the positive integers. You want to compute a sum of all non-empty contiguous subarray and then sort them in a non-decreasing order and then creating a new array of n times n plus 1 divided by 2 numbers. So given an array of like size n, if you're creating a new array in that way, your new array will be a size of n times n plus 1 divided by 2 numbers. And then we given the index left to index right, index from 1, and then inclusive. And then we want to return the sum of the numbers. And since the number can be very huge, we want to return it in the modulo of 10 to the 9 plus 7. All right, let's look at an example. So let's say we have 1, 2, 3, 4, right? So basically we need to do a brute. If I'm doing this in a brute force way where you go into each array and then add it to a new, new array. So it's just a nested for loop when you get it from I equals to 1 and j also here. So you add 1 into here and then you move j up and then sum 1 plus 2 and then you get 3. You sum 1 plus 2 plus 3, you get 6. And then you sum 1 plus 2 plus 3 plus 4, you get 10. And then you reset the sum and then you move your I, point it here. So you add 2 into it and then you add the sum of 2 plus 3 and then you add the sum of 2 plus 3 plus 6 plus 4. So it should be 9. So at the end of the day, you get this, the first one, as a new array. This one is new array, and then you just need to sort them, and then this is your sort array. So given that for that first example, left equals to 1 and right equals to 5, this is saying from index 1, right? So here they said left 1, right 5, so they're adding 1, 2, 3, 3, and 4. So they're looking at one indexing. So this is 1, 2, 3, 4, 5. So they're adding this 5 together. But indeed, the index is actually, this is index 0, and then this is index 4, right? So that's the one thing that we take care of when we're actually doing the coding. All right, so let's just dive into the code. I will set a new array to hold like the thing, and then this is a nested for loop. So for I in range length of nums, and then I'll initialize sum here, sum equals 0. And then for j in range length of nums, and then we're starting at I, and then we can do sum plus equals to numj. So this is why I'm setting it to be equals to I, and then you just append it to the new array. After that, after the for loop, you just need to sort the new array. So it's in sorted order. And then now you can set your result equals 0. And then for I in range left minus 1. And then right. So because this is exclusive, so when we set this is left is 1 and right is 5, right? But we're going from index 0 to 4. So we set 5, but this is exclusive. So it will go up to 4, and then we want to start at 0 instead, so need to do a left minus 1. And then we can set result plus equals to the new array I, and then we can return result. So that's one problem right here. I can just submit it and show you what's the problem. All right, they actually passed 53 cases, but fail 1. So the output a big number, and the expected is this. So this is what we actually saying here in the question statement, that since the answer can be a huge number, you want to return it in the modular. So where it is actually right here when you sum it. So let's define a mode equals to 10 to the power of 9 plus 7. And then when you're adding this, I can just set this. And then you want to mod the sum by the modular. Now let's run this again, and then let's submit this. All right, so this will be of n squared in running this, and then of n log n in sorting the array. But it can be arguable that since you have more elements right here, so this is not actually n log n but n squared log n, and then you just do taking out the value and then return it. All right, I'll see you in the next video.